In this video, we're going to talk about doing some triangle proofs where we are partitioning either the segments or the sides or the angles of our triangles. Now, this is everybody's favorite, so let's just review. These are the general steps to complete a proof involving addition and subtraction, and again, this is with segments and angles, right? So we want to label our given info, write our given, that's obvious at this point. Now, if there are shared sides, overlapping segments, or overlapping angles, we know we need to use the reflexive property, right? Now, we need to figure out first which two segments or angles that we're going to add to or break up. Now, if we need to add to that segment, we're going to use addition. If we're breaking it up, we are likely going to use subtraction. So then we're going to choose one of these segments or angles to break up or add to. Now, this equation is going to go as a statement in our proof. And then we're going to see right after we break up one of those segments or angles, we're going to right away see if we can use substitution from our given or from a previous step to swap out congruent pieces. Right after that, we're going to try to break up the other segment or angle. And then again, if we can use substitution again, we will, but we might not always need to. So this is some prior knowledge proof, but again, we can just go through the process of this just so that we understand where things are coming from. Now, I don't know if I'm going to have just enough room to do this, but again, we are given that MP is congruent to ST, so I'm going to go ahead and label that, and we want to prove, I should have just done this, and we want to prove that MS, which is this whole thing, is congruent to PT. Now, the first thing that I'm noticing is that what I am given, which is right here, is smaller than the thing I am trying to make a conclusion about, right? So I need to figure out how I can get from this little piece of given information, right, to get it bigger somehow to make a conclusion about this entire segment MS, right? So I know I need to add. Now, same thing, if I look at ST, if I look at my small given part of ST, I need to somehow make that bigger to make a conclusion about this entire thing PT, right? So I know I'm going to use addition. So statement reason, let's write our givens in there. Hopefully I don't overlap too much. But again, we have MP is congruent to ST, and then our reason is given. Now again, the first thing that I like to get out of the way is if I see an overlapping segment or an overlapping angle, I like to use reflexive and get it out of the way so I don't forget. Now what I'm seeing is that in MS and PT, PS is a part of both of those, right? So PS is being shared by the two statements or by the two segments I'm trying to prove to be congruent. So PS is congruent to PS, and again, that's reflexive property. Now, going back to my general steps, what it says to do is first figure out whether we're using addition or subtraction, right? We already did that. Then we're going to choose one side to start with. So I'm going to start with the left side, and I'm going to take MP, which is what we're given, right? And I'm going to say MP plus PS equals MS. Now, our reason there is segment addition. Then what it says to do right after, and this might get a little sloppy here, so I apologize for that, but we want to see if we can use substitution. Now again, we can only use substitution to swap out congruent pieces. The only two congruent pieces I have right now are MP and ST. So that means wherever I see MP, I can go ahead and swap it out. So I see MP right here. So I'm going to make that swap. So I'm going to change MP to ST here. And then I'm just going to carry everything over, because remember, when you substitute, you're only swapping out congruent pieces and you're writing the rest exactly the same. So our reason here is substitution. That's exactly what we did. Okay, now going back to my general steps, we want to break up or make that equation for the other piece. So we already made an equation for MS. Now we want to make an equation for the other piece, which is PT. So I know that if I add ST plus PS, right? And again, when we're making our equations, if we're not using substitution, your equation should match your diagram. However, what a lot of people do is they'll go to this step 4 right here, right? And they'll look at ST, which is like on the right side of the diagram, and they'll look at, like sometimes your equation doesn't match your diagram. That's only okay if you've used substitution. In this case, I can't really explain it to you, but in some cases, your equation might look like it doesn't make sense, but if you've used substitution to get there, then it's totally fine. So again, going back here, we're taking this from the diagram. So ST plus PS is going to give us PT, And our reason there is, again, segment addition. Now, when you're using segment addition, again, your equation should exactly match the diagram. You should be able to look, and it should match and make sense. Okay, now the reason I tell you guys to do your proofs this way is because if you look at steps 4 and 5 here, you should kind of see that MS is composed of ST and PS, and PT is also composed of ST and PS, right? So we can use substitution again because, and let's do this, we'll do our substitutions in green, right? We know that ST plus PS is also equal to MS here. So I can take ST plus PS. I know it's congruent to MS. So that means I can swap it out if I wanted to. So again, I have ST plus PS here, and I'm going to make that swap. I'm going to change that now. Instead of writing ST plus PS from step 4, I'm able to write that as MS, right? So we have MS is congruent to PT. And again, that reason, we just swapped that out, right? So that's substitution. All right, so hopefully that was a good refresher. Now we're going to go into an example where we have partitioning sides of triangles. Now really quickly, just make sure this should say triangle and triangle. So it says given RE is congruent to TC. So we have RE and TC are congruent pieces. Angle REP, which is here, is congruent to angle TCG, which is here. And PC, which is this small piece, is congruent to GE. So the first thing I like to do, this is too messy for me to even look at, so I'm going to redraw these diagrams. So again, what I like to do is I'll just pick one of the triangles to keep. So I'm going to choose RPE to keep. Like, I'm going to draw it exactly how it is. I'm going to draw another triangle and not worry about labeling the letters just yet. But guess what? It gives us the letters. It says prove triangle REP is congruent to TCG. So I can kind of identify the corresponding pieces there, right? So R comes first and T comes first in the name. So I know R and T go together. E and C both come second. So I know E and C should be in the same spots. And then P and G need to go in the same spots. So I want to make sure I carry over my labels too, though. So we have RE is congruent to TC. I'll fix that, put one tick mark there. And then we have that angle E is congruent to angle C. And lastly, we have that PC is congruent to EG. Now, we can't label that yet because notice that PC is not directly a side of any of the triangles yet. And that's kind of a dead giveaway that I know I'm going to utilize partitioning here because one of my given statements, right, it's only giving me a piece of this. It's only giving me PC and EG. Those are only pieces of a side. They're not an entire side. So that's a dead giveaway. I know I'm gonna need to use partitioning somewhere in here. So let's just get on the roll right now, and we will work through the logic in a bit. So let me just make sure I write all my givens down. RE is congruent to TC. We have angle REP is congruent to angle TCG, and we have PC is congruent to GE, and that is given. Okay. All right. Now, just by looking at my diagram, I'm given a piece of information about each part of like the bottom sides of both. So, right, like PC is like kind of over here, and then EG, if we flip our triangle around, it's also like in this general vicinity, right? It's giving us this portion. So I know I'm going to use that, and I'll eventually be able to make a conclusion about this entire side here. And if I can do that, right, because my goal is to prove my triangles are congruent, I'm going to try to be able to use side angle side here. So that's just a general, I like to kind of like take a step back from the proof to see what we're dealing with and what my game plan is going to be. And right now that's my goal. I want to try to make a conclusion about PE and GC. So I can kind of pretend like the rest of the diagram isn't there, right? Like if you physically cover the top of it with your hand, if you just look at segment PCEG, it kind of looks like the example we did on the previous slide, right? So we have information about PC. We have information about this small piece here, and we need to somehow make a conclusion about PE. I'm using addition, right? I have to add on to that small given piece. So let's do that. So I'm just going to get on with it. So we have C plus CE is equal to PE, right? And again, that is segment addition. And I cheated. This is going to be my step 3. My step 2, I have to notice that CE is overlapping. So we got to get that out of the way first. CE is congruent to CE, and that's going to be reflexive. Props to you if you caught on to that. Okay, now after we've used segment addition, we want to see if we can use substitution to swap anything out. So this is the only thing right now that's going to help me. So PC, I'm going to take that and I'm physically going to swap it out for what it is congruent to. So I'm going to rewrite this equation as GE plus CE equals PE. And again, we just swapped that one piece of info out, so that is substitution. And then let's break up or add up to make an equation for the other piece. So the other piece is EG, right, which is here, but I'm going to rewrite it like I wrote EG as GE here, so I'm just going to, instead of writing EG, I'm going to keep it consistent because it's going to help me see some patterns. So GE plus CE, and again, this is just coming from looking at the picture and breaking up this large piece here. That's going to be equal to GC, and that is segment addition again. Now, let's see, we can't use substitution again, or we can, but let's see what we're going to actually use it for. So GE plus CE is equal to PE here. So we're going to use this to help us, right? So I'm going to take GE plus CE and I am going to swap it out because I know GE plus CE is equal to PE as well. So I'm going to take this, swap it out for PE, right? So then we'll have PE is congruent to GC, and that again is substitution. And let's go ahead and label that. I think we finally got what we needed, right? So PE is this piece here, is congruent to GC, which is this piece here. And voila, we are able to use side angle side here. So again, we're using side angle side to prove that these two triangles are congruent. So we have REP is congruent to triangle TCG. And that is side angle side. These two sides and included angle of one triangle are congruent to two sides and the included angle of another triangle. Now, note here, like, there are going to be examples that, like, are going to use CPCTC. So in this case, right, let's say, for example, the proof statement was what I'm highlighting in, let's do purple. If the proof statement said, hey, prove RP is congruent to TG, you have to recognize that you first need to prove the triangle is congruent first. Like that, like, and this goes back to the CPCTC lesson, right? So evaluate what your proof statement is and then work backwards. Because there are going to be times, and most of your task card, most of your practice questions are going to use this, where if you see prove RP is congruent to TG, again, starting here, right, and separating your triangles is a huge first step, because if I take my proof statement and I analyze like what it's actually asking for, if the two sides or two angles you're trying to prove are corresponding pieces, you're going to use CPCTC, right? And going backwards, before we use CPCTC, we first need to know that the two triangles are congruent, right? So what I recommend doing, always, 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 draw your triangles in the correct or in the same orientation. Always do that. It's going to help you a lot, and make sure you are labeling both, right? Because here we were given that PC is congruent to GE, and that's not a part of our separated triangles, but it is a part of our original diagram, so you want to make sure you're labeling both. So we're not going to go through the second example. You guys can leave that just because I don't want the video to be too long. But just know that we can use this for angles as well. And in this case, we used segment addition, but we can also do it for segment subtraction. We can do it for angle addition and angle subtraction as well. Another piece of advice that I have is when you're trying to partition, right? Partition means we're using addition or subtraction. When you're doing that, cover the rest of the diagram with your hand. Just pretend like it doesn't exist. And then once you've made your statement, like once we made this statement here, we were able to move along with proving the congruent triangles.